All right, we are moving on to an experiment today. We are going to address two essential questions. Number one, why does water form a dome on flat surfaces? And number two, how can you change the surface tension of plain water? The purpose of our experiment today is to discover how many drops of water you can place on a penny before the water spills off. We will learn that surface tension is a property of water. And we're also going to try to change water's surface tension by separately adding soap and salt to a dome of water on a penny. All right, so these are the materials that we need. Well, a place in your home or in the classroom where it's okay to get things wet. Okay, a paper towel, maybe a few paper towels. Okay, cut them into little quarters or halves if you can. 3 small cups of water, each with 150 milliliters of water. And I'll show you approximately what that looks like, okay, because you can approximate it if you don't have a measuring tool at home. 5 milliliters of liquid detergent and 5 milliliters of salt. So when I say liquid detergent, I'm talking about something here like Dawn, okay? And when we're talking about salt, it could be table salt. I'm going to be using kosher salt, okay? And you're going to need to have at least 1 penny. If you happen to have more than 1 penny, that would be great, simply because you can prevent yourself from having to wash it multiple times. A plastic dropper, okay? And again, if you happen to have more of these on hand, that would be great so you don't have to clean between the experiments that we're doing. But if you only have 1, that's fine. And you need your science notebook open to page 4, okay? Science notebook open to page 4, and you will notice it is called surface tension. Okay, it looks just like that. All right, so without any further ado, let's get started. All right, so what I have here is some cups of water, okay? And I also have some of those 5 milliliters of salt and of dishwashing detergent that I had mentioned before. Now, I don't actually have a measuring tool with my science kit. What I did was I took one of the little Tylenol measuring cups and I used that. So this, my friends, is 5 milliliters of the detergent. Okay, when I turn it to the side, it goes to the side there, but you can look for something like that. And this, my friends, is 5 milliliters of salt. Okay, so what I'm going to do is I'm going to take 150 milliliters of water. So this syringe will take us up to 60. So we'll do 50 milliliters 3 times. So I'm going to take 50 milliliters. Okay, if you don't have a syringe, it's not a problem. Okay. And I'm going to take 50 milliliters, put it in here. So we can see what 50 milliliters is like, looks like. All the way up to 50. That's 100. And we need to add another 50. Okay, another 50 right there. And that makes 150 milliliters. So now you can continue to use a syringe, but we can approximate as to how much water that really is. And when you kind of look at it there, it looks like it's about 3/4 of the way filled. So I'm going to take some more water for 2 more cups that I have here. Okay, one's going to be pure water, which is right here. One we're going to have salt added to it, and one we're going to have soap added to it. So I'm just going to take a water bottle. It could be any kind of water, as long as it's clear water. And I'm going to fill it up here until it matches what I have in my other cup. And I will look down to make sure that it's just about equal, so we know we have, okay, 100 milliliters we measured in the first cup, and then we're just comparing it here to the second and the third to make sure it's about the same, of which it is. All right. Now, we're going to, again, if you have multiple syringes, that would be great. Okay, we want one for pure water. This is pure water right here. And we'll make this next one that I have here will be for our salt water. And I have another one over here. We'll make that our soap water. So soapy water. So I'm going to take this, pour it in here for my soapy water. Okay, if you have a little medicine thing, I'm trying to keep my arm out of the video there. Okay, make sure you get it all in there. Let it come up. Okay, if there's anything left in there, mix it up. Okay, there we have our soapy water. We have our pure water, and then we will take this and we will dump the salt into there, and that will make our salt water. Okay, and it's pretty evident by looking at them. You can certainly label it. Okay, we could put a label on here that says salt right there, and over here we could put a label for soapy, and then here we'd have our label that would just simply say pure. Okay, so this is pure, soapy, and salty water. Okay, all right, so now what you're going to do is use your tray. You're going to take your salt water, put that aside because we won't need that just yet. Okay, keep your label with it, and your salty water, and put that aside. Okay, we're going to focus here on the pure water. All right, now we want to make sure that our surface is dry. Okay, you don't want any spillage or anything there. You're going to take one of your pennies and your paper towel, and lay your paper towel down. Okay, and take one of your pennies, put it there in the center. Now we're going to make a prediction as to how many droplets of water, okay, how many droplets of water can we get on this penny before it spills onto the paper towel, okay? I'm going to say maybe 5 drops, okay? I'm going to say 5 drops. So let's see if this penny can hold 5 drops of water. Okay, and if it's more than 5, then my prediction is off. If it's less than 5, my prediction's off, right? So I'm going to take my dropper, try to hand out of here. Okay, and we're going to do 1 drop at a time. Being very careful as we're doing this that we don't spill it onto the paper towel, so we have to start over again. And we're going to count 1 by 1, okay? Now, yours might be different than mine, because there's going to be a range, and that's okay. So there's 1, and let me focus mine a little closer. Okay, so as I drop that, okay, that's good. That was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, it spilled it over, but I don't think that spilled off the penny. I think that just touched the edge of the penny and went off. Okay, so we might need to try that again. Okay, just because I think that might have been a little bit of a boo-boo, and this is the whole idea behind the scientific process. Okay, now you have to make sure that you dry that penny, put a new paper towel down. I'm just going to see if I was on target or not. Put that penny down. I may have accidentally slipped. If we get more than 14, then we know that it can hold more than 14 droplets. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's see. 15, 16, 17, 18, 19, 20, 21, 21 drops before it spilled over. So it was only a little bit more. So I'll go ahead and make that notation here that it was 21 drops. Now, what's really cool, my friends, is that when you look at that penny, and if you look really, really super close at it, okay, there is still a lot of water on top of it, okay? And it almost looks like it has like a skin on top of it, okay? That, my friends, is your surface tension. Surface tension is what causes water to stick together and tries to form into a ball, okay? So we were able to get 21 drops on there before it spilled over. And the first time it was only 14, but I think it's because I accidentally didn't place it on the penny, but on the paper towel. So you can do this multiple times, okay, and kind of figure out what works best. But let's take a look at what it looks like. When we look at it from the side, and I know that's kind of difficult to see from the side. I'm going to try to take a screenshot with my camera here without spilling it over if possible, so you can see what it looks like from the side, because it's super cool. Okay, so I got my phone here, and again, if you're doing this on your own, okay, you just need to turn your head and look at the side of it so you can see. Okay, let me take a shot. Let's see what that looks like from a side view. Okay, does everybody see that from the side view? How it looks like a dome. Okay, it looks like a dome. That's super cool. All right, so we're going to go and take a second to go over in our workbook page, which is page number 4, because we want to make sure that we're doing our observations, okay, between the different parts of our investigation. All right, so we're going to draw a picture. And I already started to sort of draw a picture here because it looks like a dome. And we're going to write that what happened with the shape, it formed a dome. It held more than my prediction of 5, but 21 drops before spilling over. Now, yours could be 30 drops. Yours could be 17 drops. Okay, there's definitely going to be a range there, but it's able to hold a lot more than 5. So here is my question. What happens if we repeat this activity, except instead of using plain water, we use soapy water? Do you think the surface tension will be the same? Will it be able to hold more droplets or less droplets? Well, let's find out. All right, so taking our materials again, okay, we're going to make a prediction. That was our prediction for pure. I'll stick those little sticky notes together. Put that aside. Now I'm going to make a prediction for my soapy water. My soapy water was right over here. Put that back on there. So that was my soapy water. I'm going to make a prediction as to how many droplets, okay, for soapy water. I'm going to say, I think it's 10 this time. I think 10 drops. Just hypothetically. Let's see if that happens. So again, I have a different dropper for this. I mean, if you're using pure water and then you put it in the soapy water, it's fine. I can actually use I think I might have a different penny this time. That may change the way the results are. So let me try to use the same penny. All right. So just go ahead and put down my paper towel and put down my penny. Okay. And we're going to repeat the same thing that we just did, except using soapy water this time. All right, so here we go. Here is my soapy water. Let me get my arm out of there. Let's see what happens. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, it's spilled over at 10. So what happens with the soap then? That spilled over at 10, and that was definitely on the penny. And friends, I'm seeing somewhat of a dome, but not really. The soapy water is kind of doing something a little bit different. I think it's flattening and making the dome spill. That's what I think. So I'm going to take my observations for that. Okay, it's definitely flattening the dome for sure. And I'm going to say here that it's definitely going to be much flatter. Okay, flatter, maybe even less than that. So for soapy water, the dome is a whole lot flatter. Okay, so I'm going to say that it flattened the soapy water, flattened or spilled the dome. Okay, it held 10 drops before spilling, because the soap affected the surface tension. Okay? Now, same thing that we're going to do again. Salty water this time. Okay? So make sure you have all your materials ready. Put this back up again. And we are going to make a prediction as to how many drops our salty water is going to be able to hold. And I've got the same penny here. Okay, so I'm going to use the same penny just to try to keep my experiment consistent, just in case the pennies are a little bit different from each other. So I'm going to dry it off really, really good. Okay, I might even put it in my clear water again, just to make sure there is not any soap residue left on the penny, because that will affect our results for the salt. All right, so for the salty water, here it is. Wipe this down a little bit. Okay, and put salt right there so we know that we had our salty water. And I have a fresh paper towel. Okay, same penny. Okay, and I'm going to write a prediction. My prediction for the salt. Okay, it's going to happen with the salt. Is the salt also going to affect the surface tension? Okay, let us see. All right, same thing. I'm gonna say maybe, well, the soap affected it. So yeah, there's salt in there. The salt's probably gonna affect it. So I'm gonna say, I know my first one was 20 drops. We had 14. I'm gonna say 15 drops before it breaks the surface tension, just as a prediction. So let's see if salt has the same effect that soap does. Okay. All right, I'm gonna mix this up, get my hand out of there. Okay. Oh, mixing it up, making sure that salt is really dissolved in the water. Okay. All right, filling up my dropper. My dropper is full. Now let's start counting. 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to make it a little closer so you can see it without shaking it. That's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17 before it spilled over. I was pretty close with my prediction there. But what I noticed, friends, was that unlike the soap, okay, the dome was still there. It really didn't affect the dome. I ended up with 17. 17. So let's make our observations here. So with salty water, it definitely was not like the soap. It did not decrease it or flatten it. I still had a dome there. I'm not sure that it was as high as the original one, but it definitely still formed a dome. It formed a dome. It held 17 drops, okay, of water. And I'm going to say that it has really it has little or no effect on surface tension because it held 17 drops, which is close to our 21. So it did not really affect the surface tension. I saw a dome. Okay, you definitely saw a dome there. Now, and you can repeat that as many times as you like. The soapy water definitely affects the surface tension. The salt water, not so much. Okay? All right, so now we are asked to describe surface tension in our own words. So it kind of looked like it had a piece of skin covering it, right? When we looked at that in our video. So I'm going to say that surface tension makes water form a dome. Surface tension makes water form a dome. Soap breaks it, but salt really doesn't. Okay? And that, my friends, is the end of this lesson. I hope you enjoyed it. I hope you had a good time learning about surface tension. Next up is a science story on surface tension. Stay tuned. Here we go.